This video is to help you with Angular Calculations 1. This is a fairly simple exercise as long as you understand a couple of geometric principles, and I also want to explain the use of typical dimensions to you. Typical's pretty easy. I'll just demonstrate here. For example, if I were to take a linear dimension from the highlighted line you see here to the highlighted line you see here, and you were given a typical dimension, for example, let's say this will be different than what's in your workbook, but let's say this dimension from blue line to blue line is 1.00, and if I had a 1 followed by TYP, that means that the linear distance between all the blue lines would be 1. Okay, same thing for the red. If I had a linear dimension between the red line and the red line, and it said dimension 1 typical, or TYP, then I can assume that all the measurements between the red lines measured perpendicularly have a distance of 1. Same thing with the angled lines. Okay, so that continues on across. Now in the book they give you a typical angular dimension. So let's look at what my drawing is. It's going to be a little bit different. Okay, mine is 42. So that means that anytime I have a blue line and a yellow line, the small angle between the two will be 42 degrees. Now, with that being said, that one angle implies several other things. Okay, so what I'm going to do, I'm going to clean this up, and I'm just going to leave one of the yellow lines and one of the blue lines and one of the red lines, or at least that's the plan. Let's see how many of these I can correctly get rid of here. Oh, good. Alright, so I have 3 lines left. I have the horizontal, the vertical, and the angled. So that 42 degree angle implies some other things. Okay, one geometric principle is that when you have 2 intersecting lines like you have here, if this angle is 42, then this angle over here is also 42. Okay, and I will actually dimension that so you can see it. Okay, well, what it also implies is that if you if you have 4 angles basically created by those 2 lines, you have the 2 that are dimensioned here, then you have the other 2. You can take 360 degrees, subtract 42, and subtract 42, divide that number by 2, and that will give you the angular measurement between, it'll give you the large angular measurement. Okay, so let's actually, and I hope rounding doesn't cause some kind of error here on my, because these, even though these angles say 42 degrees, they're not actually 42 degrees, they're rounded. Okay, so I may end up with an error, so let's just see what we have here. But I'm saying that if you take 360, which is the number of degrees in a circle, subtract 42, and then subtract 42 again, you're left with 276. Well, divide that by 2, and that's 138 degrees. So that should be the angular measurement, the large angle between the blue and the yellow line. So let's see if it is. And if it's not, it's just because of rounding, but I think it probably should be. So 138 degrees and 138 degrees. That also means that the angle between here and here is also 138 degrees. So those 2 intersecting lines mean a good deal as well. Now, you also, when you have a horizontal line cross a vertical line, it forms 90-degree angles. Okay, so if this angle is 42 degrees, that means that the angle between the yellow line and the red line is 48. Okay, because it's 90 minus 42. So let's measure that. Okay, so that's 48. If you want to figure out the large angle, let's see, say between the red line here and the yellow line here, you could, well, you know the angle of a straight line is 180 degrees. So if I want to know the angle between here all the way around to here, I just add 180 to 48. So that's 228. Okay. So just from that 42 degree measurement and understanding that we have a horizontal and a vertical line crossing forming 90-degree angles, we're able to figure out a lot of the other angles in the drawing. Okay, so as you work through the different dimensions, just go through and look for those similarities. And let me show you one more principle here. I may have already touched on it, but just to make sure, if I have two parallel lines that cross and one line intersects those parallel lines, what this is telling me is, since this angle is 42, this angle between here and here also has to be 42. Okay, this is again another geometric principle, but just to show you, I'll measure that there. Okay, so that is also 42 degrees. All right, what else that is implying is that if I were to take a line and draw from the intersection here perpendicular to this line, I would create a triangle, which you might be able to use. Okay, and in that case, again, we'd be looking at, since we created a 90-degree angle here, 90 minus 42 is 48 there. Okay, we've seen that before. We saw that on the previous diagram. Also, if we wanted to figure out the large angle between the yellow and the blue, we could take that 48 and just add 90. So that angle would be 138. Okay, so even though your drawing looks kind of busy, okay, in the workbook you have a lot of lines crossing, it really only only 3 or 4 of the lines really matter. Okay, so maybe you want to do something to highlight just 3 of the lines and work through it like that, and maybe that'll help you through the exercise. And that concludes this video.